So welcome everybody to the Best of the World Webcast Series. The goal of this series is to bring to all of you some of the best security researchers across the globe. So we have a very high bar in terms of the speakers. They are only those individuals who have made some contribution in terms of like original contributions in the field of security. Only for those speakers we call it Best of the World Series. So today we have a great security researcher in the field of OS security, and we got today Jacob Torrey. Welcome, Jacob. How are you doing?
Thank you, everyone. Very well, thank you. How are you?
Doing great. Great to catch up since we met last time. So a little bit about Jacob. He is one of the well-known security researchers in this field. He leads the computer architecture group at Assured Information Security. And Jacob has worked extensively in the low-level x86 and MCU architectures. He has written BIOS, operating system, hypervisor, and SMM handler, and has spoken in some of the topmost security conferences across the globe, like Black Hat, etc. So I understand operating system is one of the really hard subjects. It's my last exposure to operating system was when I was in school. After that, it had been mostly application security, and for sure I would say application security is a lot simpler. So we would hear from Jacob today and learn from him what are the latest attack vectors in the field of OS security and how the security has evolved over past decade. So over to Jacob, and post his presentation we are going to have a little bit of discussion and Q&A. So any of you, if you got any question during the discussion, please feel free to just type in your questions either in the chat box, or you can see the questions field. So you can please type in your questions. We'll take it up towards the end. So Jacob, over to you.
All right, well, thank you. So yeah, as I said, my name is Jacob Torrey, and I'm going to be talking about some of the operating system and hardware threats, things that are very commonly overlooked, especially when you're doing kind of a security analysis of your organization. And so I wanted just to kind of highlight what's out there and then kind of go through a few exercises just to kind of put it in the back of your mind, but then also kind of temper these threats that I'm going to talk about so that you know that, that's not something you need to immediately run out and be concerned about. So we're going to go through a little bit of introduction and background just to kind of bring everyone up to the same level. The technical information here is going to be what I would say pretty high level because as the moderator said, a lot of this stuff hasn't been really seen since university, so unless you're working in it, it's a little bit difficult to keep abreast with the latest and greatest. And we'll talk about who you're trusting in your organization, even if you don't realize. So we're going to kind of go through an exercise of mapping your trusted computing base on your organization, and then talk about kind of some of the less is more, the least privilege principle. And then finally, just kind of a wrap up as a little extra, talking about kind of ways to sell information security to your organization. And so a lot of times I see in organizations that CISOs are constantly seen as the bad guy. They're bringing in costs and they're telling people no. And so trying to find ways to make information security seem like a thing that an organization really wants to invest in. And that becomes very important, especially after these latest breaches. After that, some conclusions and then discussion through the moderator. So traditionally, computer architects as well as software architects kind of have been focusing between performance and cost. I'm sure those of you who have led a development project in the past, or looking at how you would sell a product, you imagine you have a marketing slick sheet. on there you can have a couple different bullet points highlighting the different features. Performance and cost are some of the biggest ones that people are looking at when they're looking to purchase software or a hardware feature. Unfortunately, security is not there quite as much. Security can be very expensive to get a very high level of assurance, but it still only takes up one bullet point on that marketing slick sheet. Whereas if you added some extra features which might lower security or reallocate some funding, you're going to get some more bullets on your slick sheet so that you can advertise your product as the latest and greatest. So security, my thesis is that it's not only a software issue, it also needs to be considered by people who are developing computer architectures and then kind of the interaction layer between the two. So I would call that the firmware or the operating system level. And so that's what I really want to talk about today is we're going to go through a couple case studies and look at kind of some failings out there and some threats, and then discuss whether or not they were intrinsically kind of design issues or whether or not they were something that is just an implementation flaw, a bug that could be easily patched. So we're going to start looking at the x86 architecture. For those of you who are not familiar, that's the standard Intel Pentium and then Core I series processors, starting at the 8386. And so that's kind of a very common system. You'll see it in servers and desktops quite a bit, and it's kind of only lately been threatened by ARM. And then we're going to talk about the source of each of these vulnerabilities and then discuss the impact and what you should be doing to prevent them, both in your organization and then if you are actually kind of undergoing creating architectures in the future. A lot of this can parallel into software and hardware. So right into some background. I want to preface this talk with something I've been talking about with a few researchers, which is the chess versus poker problem. So I want to kind of set the mood for this talk. And so as an information security researcher, I get invited to speak at these conferences and get considered probably undeservingly best of the world by presenting new cutting-edge, elegant research. And that is, in my mind, like a chess problem you'll see in the newspaper where you have a certain board configuration and it will say 3 moves to checkmate. And you have a very kind of constrained and aligned initial starting condition and then a very elegant and masterful solution, which is what I would say is the kind of the main thrust of information security research. That being said, the attackers and the users of technology focus on the ease of use and convenience or the return on investment. And so I'm rewarded for the neat tricks and elegant exploits, whereas you as an organization and the people using it are rewarded for kind of deploying solutions and new defenses. However, the issue is that attackers, they're not motivated by neat tricks. If they can steal your password and guess your password because your password policy is very simple, and even though all of us as information security professionals know to have a good password, if our users don't because they just want to use the internet and their IT infrastructure to get their job done, the password is not something that's really in their forefront of their mind. And so that's where you kind of have this thing where we're focusing on these very small edge cases. So if you look at like Microsoft's anti-reverse or exploit tool, the AMET tool, watching the latest research in that go back and forth is very, very interesting to me. But I would say that the vast majority of the security problems we have today come from phishing or just poor password strength. So the thing about, I would say, cyber or the information security realm is that everyone who uses technology is an information security practitioner. Cyber civilians or professionals like us. And that's something that's kind of very uniquely different from the physical world, in which me as a normal citizen, I would never have to be concerned about having an invading army and having to defend myself against that. That's what the military is for. However, in the cyberspace, because we're all on a flat domain and network, I'm out there on the front lines of it just as well as my mother and my grandmother who just want to accomplish their goal. They want to look at pictures online. They want to use the technology to kind of enable a social experience. Attackers are motivated by a few different things. I would say that money is a big one. I think it was in 2009 they found that the amount of revenue in cybercrime overtook that of drugs worldwide. And so now that cybercrime has become very commoditized, you'll actually have people developing malware, selling that to someone who will go out and infect it, and then someone will basically sell an Amazon cloud of a botnet that was created. And this kind of become a kind of very efficient market. So if you're motivated by money, the easiest way to make money will provide your highest return of investment. So if I'm an attacker and I have the kind of the option of guessing someone's terrible password or going in and creating a 0-day against maybe multiple softwares to kind of get this very elegant hack, all the time that I spend building that 0-day chain is money that's wasted. That's time that I'm not returning, providing a return on investment. There was a great talk this year on Black Hat about hacking 4G wireless modems. And the attack itself was very uninteresting, and I was surprised it was at Black Hat. But the method that we're using to kind of monetize that was very interesting. All they were doing is they found a small JavaScript bug that would then send text messages to one of those premium text numbers, and they were making $10 a minute for each compromised host. And so that I find to be a very interesting kind of divergence between what me as a researcher and you as practitioners, and then what the attackers are motivated by. They want to do the lowest thing that they can do to get the return on investment. Then some attackers are motivated by revenge. It seems like this Sony hack that's breaking is destruction. It doesn't seem like they're doing a very good job of capitalizing on their documents that they've discovered, and their goal is brand destruction, and they're not really worried about kind of covering their tracks other than to prevent attribution, but their real goal is destroying the company. I would call it a denial of business attack. And so those attackers are much, much more scary. That's really an operational security concern. If you have an attacker out there that's specifically targeting you for revenge, then you have a much harder adversary model, whereas if you're just kind of keeping yourself safe from monetarily motivated attackers, what you really need to do there is just kind of be a little bit better than everyone else, because the easiest way for them to make their return on investment would be to hack the easiest one. It's kind of like that saying about if you're being chased by a bear, you only need to outrun your friend, not the bear. I think that's pretty similar, though the bar might be a little bit higher for that. And then last, fun. So a lot of this is the kind of script kiddie attacks, which are very automated, and it's quite easy to protect against, and as long as you're not what I would call low-hanging fruit or soft targets. We had a research project where we set up a SSH honeypot that just listened on port 22 for what passwords are being guessed. And I would say that the top 25 were the ones that you'll see every time a password. 1, 2, 3, 4, God, etc. And those ones really highlight the fact that it's somehow providing some return on investment for either the attackers, be either that monetary or just for fun and education, that it's still worth doing that. And so the fact is that they're still somehow kind of getting some return from guessing the word password. There must be enough people using that. Similarly, you look at a kind of a massive phishing attack. I don't know anyone who's ever tried to go and buy adult medicines from spam, but the fact is that they're still doing it because someone must do that, and then they're able to monetize that. So when you see these threats out there, you have to realize that people wouldn't be doing them if there wasn't some payback for them. So now we're going to talk about some pretty scary attacks. I want to preface this by saying these are unlikely to be used against your organization. I want to highlight that there's always a way in. So you want to make sure that your attacker is not the target of a sophisticated attacker that's kind of motivated by revenge or specifically targeting your organization over just any organization in your market segment. And so these right here are more kind of on the, I would say, the poker or the chess problem side of things. These are what is the cutting edge research, and just as kind of a way to realize that 100% security is never possible because there's always a way in. So a little bit of background. We're going to talk about VMX. So basically what this is it's a hypervisor. So if you're running VMware or Zen, you're actually running a VMM, which is just a way to kind of abstract the operating system from the hardware. So you can run multiple operating systems as if they were applications. Unfortunately, the implementation of VMX can be enabled and disabled at any time, and it was designed to improve performance and the amount of your system that you're able to use. So rather than having 3 very lightly loaded mail servers, you can now have one that's going to be much heavier loaded, but you're still going to have some of the same isolations, at least logically. So from a maintenance and management perspective, VMX was kind of designed with the performance and the cost metric. There's another type of virtualization on the IBM mainframes, which is much, much more expensive, but has much stricter isolation. And that was kind of down to security. Though I would say, seeing how the latest, the latest market share of Google and Apple, and they're using the commodity cloud, I would say that the performance and the cheap, the low cost of this VMX in Intel is winning out over the more expensive but more secure ZOS hypervisors. So this is a pretty old attack, actually. This was back in 2006. It's a blue pill. It's a rootkit written by Joanna Batowska, part of Invisible Things Lab, and was presented at Black Hat. And essentially, the issue with VMX is that there's no way to know if you're in a VM or not, if that VM is on purpose trying to be stealthy, and unless there's already a hypervisor in that kind of VMX slot, there's no authentication needed. There's not like a Windows dialog that pops up and says someone is trying to start a hypervisor in the architecture. So the issue is if modern Windows systems up until 7 didn't by default run a hypervisor, and so Blue Pill could just come in and say, oh, I'm by default authenticated because I'm running on this system, and then it allowed you to get more privilege in the operating system, which gave you a hidden execution environment, and you were completely safe from defensive software. You had more privilege than your anti-rootkit and anti-malware. This is a very, very stealthy rootkit and one that's very hard to detect. And so this is kind of what I said right here is basically Blue Pill, because there's no authentication either for the user or from the machine. As long as there's nothing there in that kind of slot, you could say, Blue Pill can just stick itself in there and then be able to subvert your system. So what went wrong here? Basically, you have an environment that if you have some kind of secure enclave, that secure enclave can many times be used more effectively by an attacker. And so an attack, basically this hypervisor slot is protected using hardware features to prevent an operating system from breaking out of that or violating the isolation guarantees. Unfortunately, that's also the perfect spot for a rootkit. And so these technologies really need to be given extra attention when they're architected. And basically, if all they provide was a single instruction that you could guarantee would tell you if or not there was a hypervisor, you could at least detect if you were being compromised, but they don't have that. So that's kind of this implicit authentication once you're running that you'll see many times in hardware. We're going to jump a little bit to some much more recent work, 2014, by Corey Kallenberg and Zeno Kova out of MITRE. They showed that the reference implementation, which is provided by Intel, is open source, and which is then pretty much copied and pasted into all the different BIOS manufacturers, allowed you to escalate from a user application, which is the lowest privilege. That would be a Ring 3, so that would be your calculator or Notepad or Microsoft Word, all the way to the most privilege, which is your firmware level. So they could infect your BIOS from user space. And that was a very extreme attack in the sense that they were able to go from the lowest privilege on the system to the highest privilege, even more privilege than a hypervisor. And so this was a very scary attack. Really, the worst part about it is that even though it's been fixed in the reference implementation, people don't patch their BIOSes very often. It's not something that kind of pops up in the corner and says, hey, you have a software update available. It's something that requires a lot more manual interaction. And also it can be a little bit risky. Sometimes if the power goes out while you're doing that, you can brick your system. So that's the scary part, is that these attacks will be around and vulnerable for quite some time. We're now going to talk about the work I presented at Black Hat. It's called More Shadow Walker. It basically showed that you could misuse the existing x86 hardware to be able to hide malware from operating system protections and antivirus. And so This will allow you to bypass anti-kernel patching, so that would be Microsoft Patch Card, and antivirus could not detect modifications to code. And it did this by providing a split view of memory, code versus data. And so if you have a region of memory in application, say you want to check the Word application, you'll know where it is in memory and you'll read through it and verify that it hasn't been compromised. Unfortunately, with my technique, if you were to read memory in the CPU level, it would actually go to the benign copy. But if you were to jump to that memory and actually run Word, it would give you a different output. And so there's no way to actually measure what code is running on your software. You can completely kind of remove all trust in the ability to measure your system. So that was pretty scary, but again, very rare attack, but something that shows kind of these issues with x86. This is actually one of my favorite, 2013. It's called Stepping Pwns. It showed that you could pivot through a printer, and that would allow a remote shell from behind a firewall, reverse shell. And so what the kind of the attack scenario was is this researcher would email an organization with a PDF that had a firmware update for the printer in that PDF. Since this wasn't, a Windows virus, it would not show up as malicious by any of the antivirus software, even ones that, like FireEye, that kind of run in a VM or do behavioral analysis. But when you were to print that document, that PDF, so he would ask, the HR person, hey, here's my resume, please send this out, and print it out and send it out to people. As soon as the printer received that PDF job, it would upgrade its firmware to one that he had compromised, and then open a reverse shell through his firewall. He could then pivot from that and infect IP desk phones and smart switches for a stronger foothold. He went one step further and created a network inventory automatically of all the phones, printers, and switches that he had been able to compromise, and then monitored them for being maybe reset. So if you went and you detected something was screwy with your phone and you kind of reset the firmware, it would detect that that phone had been reset, and they would reinfect it. So the only way to remove his compromise from your network would be to shut down every printer, IP phone, smart switch, and reflash them all offline at once, and then bring them back up. So this was a very impressive attack, showing that especially now with bring your own device. Bring your own device is traditionally used in the concept of mobile, but there are many devices that are running code on your network that are not kind of your standard Windows or OS X or Linux systems. And unless you have you don't have an antivirus or a patch solution for your printer or for other devices on your network. And so that's something to think about, is that you're implicitly trusting in the resilience of the operating system running on all of these devices. And typically they don't provide the access for you to go in and examine that. They're very rarely open source and don't allow you to load arbitrary code on there like an antivirus for your smartphone or your IP phone. So why does it matter? The issue is that insecure hardware could be used to attack a system and then also hide from defensive and forensic software. And it provides a very big challenge to protect a system building on insecure hardware. It's kind of like building a building on a very weak foundation. And so it's a real challenge for defensive software if the offensive software, the attacker, is at a higher privilege level. And hardware cannot generally be fixed as easily. So, the one fix might be to replace the hardware. A lot of times, Intel will put out a BIOS update which includes a microcode update. But again, these are very, very rarely applied. And so the patch coverage of that versus, say, something like an Internet Explorer bug is much smaller. Let me talk about technical debt. This is a term, a metric used to kind of get a quick metric on how a software development project is going. And so this kind of tracks the growing gap between the product in reality and in a perfect world. So, there are some things that you would do where maybe you'd invest a little bit more time up ahead of, and you'd spend a little bit more time before you got to market, but then you'd have a much cleaner product. And that would be basically accepting little technical debt. So if you accept absolutely no technical debt and everything is architected and designed and there's no deadlines essentially, you'll get to the market late, if ever. If you take on too much technical debt, and so you're basically taking shortcuts or you're going to kind of compromise your market release time, for your maintenance, your product will be unstable, it might not scale well, so if you end up kind of coming out and you're providing the software as a service, maybe when you tested it on a small number of users, everything worked well, but as you scale that up, and you're going to see that it's going to become unstable, slow, and impossible to maintain. And so it's a helpful concept to sell product investors or stakeholders in your organization on spending some extra money on development. So a little bit more now will save some money later. Maintenance over a life cycle of 20 years may outstrip the initial development costs if you take on too much technical debt. And this is a really good way to kind of have that dialogue with someone in your C-level staff, so maybe a CFO or a CEO, if you're building a software, to say, okay, here's the kind of the trade-off, how much debt, so to speak, are you willing to take on? And what's interesting about this as well is just like your mortgage or your car loan, it kind of grows over time as your developers come in and out of your organization. Bits of that kind of inherent knowledge of how that application works is going to leave, and it's going to get a little bit more expensive, and you're not going to have it running on the latest hardware because it might not support certain things. And so it's going to kind of grow at a fairly constant rate, but it's something to kind of keep in mind, just like having it on the books for your fiscal debt. And this is the last part of background. So the trusted computing base. This is basically what code is executing as a privileged container. And you can define privilege in many ways. So this could be something that anything the administrator runs, any administrative software. This could be defined as your operating system, your kernel, your hypervisor. And then I think the most important one is access to sensitive data. And so this could be even the most untrusted software. If it has an access token to your sensitive database, that's part of your trusted code base, because you're trusting that that piece of that application is not going to be compromised or misused or used incorrectly to access that data, which is really what you're trying to protect. So the goal of kind of doing this analysis is to shrink this as small as possible. And I would like just to kind of go through an exercise of kind of talking about what a trusted computing base looks like on a standard system. And then you want to be looking at, okay, how can I measure and protect this code base? Because anything that's running that's outside of this code base that doesn't have access to your sensitive data, it's really something that is just kind of an extra overhead for you to be looking at, and something that is not really a high priority. So this is very challenging, unfortunately, because there's so much running on your computer in the background. So here we're going to talk about just turning on your Windows computer. This is like a Windows, say, 7 computer. Your BIOS is loaded from your ROM, which is a chip on the motherboard, into your main memory. So now you're immediately trusting the BIOS vendor. So this could be any of those kind of Phoenix BIOS or any of the other ones. And a lot of that code is copied and pasted from Intel, as we saw earlier, and so it could have vulnerabilities in it. Conveniently, this is generally hashed and checked to make sure. Then the BIOS loads any opt-in ROMs off the devices. So this might be if you have a RAID controller that needs to kind of initialize itself, a video card that needs a special driver, or if you want to do a boot off the NIC. Now you're trusting basically the vendor or the driver developer for every PCI device or ISA device you have in your system. And now you're then obviously trusting your operating system vendor, which can be checked and could be run under virtualization. So then now you're also trusting your hypervisor vendor. So we haven't even got to the point where you're at the login screen, and you're already trusting half a dozen different organizations, not only to them that they have no vested interest in compromising you, but that they're meeting the standards that you would meet. You'd want to have kind of assurances if you were doing a vendor search. So if you're out looking to buy a firewall product, you're going to make some certain assurances to make sure that this firewall itself doesn't have the software vulnerability. Here you're kind of in the dark because just by adding an extra graphics card to your server, you've now increased the trusted code base, probably without a full vendor review. So now that your application is running, you have libraries and toolkits that you link against, and then drivers for every device you install. So if you plug in a USB device, it'll run a driver run by that vendor or individual. Linux is a very common example of this, where you'll have some kind of tinkerer hobbyist developer who will want to be, support some USB device he or she bought, and he'll write a driver that works specifically for that device, but then it'll get included in the kernel. And then if anyone plugs that device in, or a device that emulates that device, it'll run this driver probably written very poorly. You also look at everything running with more privilege in your application. So that would be antivirus, digital loss prevention, OS, hypervisor, BIOS, firmware. And then a bug, could be the entry point for this. There was a great graph at the ShmooCon keynote in 2011 by Mudge, who's a DARPA program manager, highlighting and showing the code base size for the attack software, so exploits he had gotten over the last 20 years, and defensive software from early firewalls all the way up to kind of the McAfee host-based solution. And the attack software, exploit software, has remained pretty static at about 100 to 200 lines of code. And so if you assume maybe, I don't know, so some fixed amount on average bug per line of code, that's pretty rare to have a bug in 200 lines of code. The defensive software was growing at an exponential rate. I believe, HBSS, the McAfee endpoint solution, had over 10 million lines of code, which is more than many operating systems. And so again, if you can do that simple average calculation of how many bugs per line of code, you have a huge attack surface by running defensive software. And then also you can consider a malicious developer that's going to add, a backdoor to your printer driver. There was a pretty recent kind of news story where a company was, their business model is they want to prevent people from buying and using counterfeit devices. And so they actually used the driver that they had been signed by Microsoft to detect if you had any counterfeit devices connected to your system. If you did, it would brick the device. And so this is basically kind of a collision between your business and organizational goals of doing your job and using these devices to kind of, enhance your productivity, and you most likely didn't even realize that it was counterfeit, versus their business goals of selling as many real devices as possible and making counterfeiting very unattractive. And so this is something where you see, you're basically implicitly trusting a business that might have a very different goal than you do. Now we're going to talk about pivoting. So attackers are quite lazy, and this kind of stems from the fact that they want to kind of maximize the return on investment. So they're going to aim to accomplish goals as quickly, as easily as possible. And it's very easy to attack a legacy service running on an old server under an employee's desk than a fully patched and firewalled server. And so once you get access to these soft targets, you're going to perform recon and then pivot to goal systems. This may happen multiple times. So this happened in the target attack where they found a vendor, a vendor access to some HVAC system, which was their soft target, and they were able to pivot multiple times to get down to the POS systems, and it was a huge attack. So unfortunately, a lot of organizations focus on perimeter defense. So they might have a hard exterior with firewalls and IDS and IPS, but then they have a soft, gooey filling. So once you're through, it's very easy to move around. So if you imagine that printer attack, you might have a very strict kind of incoming firewall detection, but once there's that reverse shell out, once you're inside, you can easily compromise the whole system. And so once the perimeter's been breached, it's kind of game over. And so this is kind of the less is more. So this becomes kind of the least privilege principle, but extended to your entire network's trusted code base. And so, basically if you host on the cloud or with a cloud model where the clients accessing that data are kind of untrusted, so to speak, but you have your, your databases and your applications kind of running in a very small, kind of individual protected, you can deprivilege most of your organization's network. So here you'll see a standard organization where you have a network with services, appliances, and user machines connected to the internet. And there's some implicit level of trust on these services and appliances when the originating request comes from a user machine. And so if I was an attacker, if I could compromise your firewall, I would go after an unpatched user machine and then pivot from there. If, however, you move to where your services treat the user machines with the same amount of trust as they would if someone was connecting from home, which is, say quite a bit less, now you have a much smaller attack surface. So now if someone compromises your user machines, they haven't gotten much further than as if they were compromising, any computer that's used to access your network. And so you can kind of see this, like, a lot of people have been moving to hosting their email with the Google or the Microsoft cloud, so they can access it from their cell phones, their home computers, wherever they might be, and it kind of really removes the amount of trust that you have, where you don't have a direct trusted connection with authentication tokens to the server that might also be running, on the same system as something else. So, in this small example, you then shrink your trusted computing base to only include the cloud applications, And if I were to attack your organization, your office network is much less beneficial to me. It's also much harder if I'm doing recon. I'm going to start with kind of figuring out where your office is, and maybe the IP addresses of your firewalls, and trying to figure out as much information about your home network as possible. But if you were able to kind of move your sensitive information outside of that, I'm just wasting my time. So if I'm monetarily motivated, I might give up. And I might, if I'm motivated by fun or even revenge, I might, again, give up because it's more difficult than I thought. And you're less trusting in unknown entities other than the cloud provider. So, someone who in your organization's network is allowed to install arbitrary software, that's increasing your trusted code base or trusted computing base if your service is running behind your firewall, kind of adds a little bit of implicit trust to internet machines. Now we're going to kind of shift as we're kind of coming up to kind of towards the end here. Selling information security. So I've worked with some CISOs here in the U.S., and it is really literally $1 million question. It could be even more in some cases. And the question is how do you communicate the value add that security can bring to an organization when it's constantly seen as a cost or a roadblock? So when you're developing software, a lot of times you'll have some software that comes out and you're ready to kind of deploy it across your network, and then the CISO or the director of IT security comes and says, oh, you can't do that, that's far too risky, or oh, we need to stop and kind of evaluate this for a month before we're allowed to deploy it. And then obviously, it's always a kind of a battle at the time for, the budget when you're trying to say justify security other than just, basically we're going to try to stop you from getting hacked. And so I kind of broke this down to 3 things and a little bit of a framework. And then one other thing is just knowledge of when enough is enough that hopefully can help you at least kind of communicate in the same language. So to speak to other organizational stakeholders that might have a more business or a financial mindset rather than a technical idea. And then you want a holistic view of what your threats are in your adversary model, and then some metrics to track your progress and maybe your return on investment. So, initially when you want to steer, the dialogue, you want to steer towards the positive. So there are some things, especially now with all these latest breaches, consumers are becoming more impacted by them. They're becoming more frustrated with them. It seems like, in the U.S., the joke is that almost everyone in the U.S. has free credit reporting thanks to Target, Home Depot, P.F. Chang's, etc. And so, having a strong brand, it kind of comes from securing your network. And also it can save your job. Privacy concerns are also an everyday topic, especially after some of the revelations coming out of the U.S. And customers are increasingly concerned about what their data is being used for, where it's going, and who has access to it. Especially after some of these latest insurance companies were compromised, and now that they're seeing their personal health information being sold in the black market, they're very much more concerned and much less trusting of organizations to do business with. And you'll see a kind of an increase in the number of people who are saying no. There's a big e-healthcare push here in the U.S., and it's very, very slow because so many people are distrustful of these web applications that were created by, some small startup that wants to store all your health information and be able to access it from anywhere, whereas we have a track record of, these things being compromised. And then also, by implementing a less is more kind of TCB model, you could actually slim your operations and minimize costs in the long run by kind of removing things you need to, to worry about, and then being able to kind of focus on what's the actual important, the annual summit, there was a great kind of analogy to your crown jewels. So it's maybe the 3% of your data that's worth maybe 90% of your net worth. So it's, maybe your core IP, or, who your business internal customers are, etc. And so if you can focus on preventing that data from being compromised, you're going to be able to minimize costs by not focusing on things that might not be able to access that data. You also want to be able to kind of figure out who your adversary would be. And so if you're a small company that hasn't really made a name for itself, and you're just being targeted by low-hanging fruit, they're going to be automated, they're script kiddies, they might be people kind of learning and they just kind of stumbled across your IP address randomly. That's something that okay, if that's all my adversary model is, I can pretty much just get myself above the low-hanging fruit and then I'll be able to kind of say, all right, I'm done for right now. Then you look at everyday thieves, and they're looking for a profit. They don't really care about your company in particular, and they're going to go wherever's easiest. There was an example here where a financial company was compromised. The thief, or the cyber criminal in the attack, didn't even realize it was a financial company. He just found some easy to compromise thing, and then what he did was he stole their UPS account number and was racking up thousands of dollars of international shipping fees to ship stolen goods. And so he had access to a wealth of financial information, but he didn't even realize that your company in particular, that's what it was doing. And so that's kind of the middle one, where you want to be able to kind of have a egress filtering on finances to make sure that you're not losing money by some company that's not specifically trying to target your information and monetize that. And then finally, you have your advanced targeted threat, which is the most concerning. That's one that either you've gone in the press and you've made a bad name for yourself, like Sony, or you have a competitor that really wants to kind of beat you to market. And so they're invested highly in successful exploitation, and they know how to understand the information that might be resting on servers and be able to monetize that, or at least kind of exploit that information into something meaningful. And so these are here. If you're targeted by an advanced targeted threat, that is something that you need to know immediately, and you need to be able to figure out how you're going to handle that. Whereas most everyone is kind of in the first two categories. And so knowing that you don't need to worry about an APT attack kind of really allows you to kind of narrow your focus and slim down your costs. Also, you need to know that your organization is not monolithic. So if you have multiple offices within your company, and some of them do payload processing or HR, that's pretty sensitive personal information. But say some is just a graphic design shop that all they do is they take kind of media to be published on publicly, and then they will take that information and kind of make it look nice. Those are not the same in terms of what you need to protect. And so if you're preventing, putting the same level of protections against both of those two organizations or within your organization, that's not really the best way. So if you could break your organization into logical units that, at least from the network level, are mutually untrusting, you'll be able to find some savings by kind of focusing and prioritizing on even business units that are more interesting. And then also, research competitors to compare. I said this earlier, but when you're running from the bear, you only need to outrun the other guy, not the bear. And this is actually, kind of amusingly very popular in, especially in the U.S., where there's a lot of regulations, where you can kind of tell the auditors to go, oh, go look at competitor if you know that they're much worse than you. And so the auditors will have a field day and spend 2 years auditing your competitor while you're able to kind of quietly improve your posture, security posture. And then metrics. So this is really difficult. So it's very hard to sell something you can't measure. And unfortunately, measuring security is almost very, very challenging. So the metrics must be understandable to all stakeholders. Saying that you've patched yourself against CVE 2014-099 is not really that helpful to a CFO. And so this is kind of where we're using that information security debt, which is very similar to technical debt, to translate the technical details of your progress and kind of how you're doing into a fiscal model that's more easily to align with your business goals. And you got to remember, obviously, as a CISO or someone high up in information security, you're there to support the business goals, not to make yourself the best CISO out there. And you make yourself the best CISO out there by supporting the business. If there's no business because you've turned off all the computers and disconnected yourself from the internet for perfect security, then there's really no business to support. And so this information security debt, you can start looking at that by inventorying your network, and you say each device might be some risk, and you can kind of just, kind of do an inventory and just kind of glance over a lot of these things and just kind of remember that implicit trust, and then see, okay, there's also a maintenance cost for every device. You have some patching, you have some IT support, you have monitoring, log data, and then look out and say, okay, well, on this network, which of these devices do I really need to protect, and which ones are kind of untrusted internally? And then you can look at costs out over a couple of years, and then costs over time could exceed those short-term savings. So maybe product A costs a little bit more up front, but it's automatically patched, doesn't open up ports for debugging, has a much more diligent security team. That might be a better offer down the road than product B, which would be cheaper but will require a specialized attention over its lifetime, which will then kind of distract you from your other tasks. And then you obviously want to find a balance. This is the same as when you're doing something, you have to do a risk analysis. So if you have zero information security debt, you have a turned off computer in a safe, but it's not very usable and doesn't really help you accomplish your business goals. And then this is really the question you need to work with your stakeholders to figure out is how much debt is too much or too little. You obviously never want to invest more than your data or network is worth. And will you save some technical debt at the expense of business goals? Sometimes it's worthy trade-off, but now at least you can measure and compare apples to apples. You can say, all right, we're going to take on this much technical debt. If we don't kind of prevent that, if we do decide to pay off this debt by, say, blocking these ports or shutting down a legacy application, one of our customers we might have to move, and that might be an expensive move, but it would be one time, and then that way, we're kind of protected in the long run. And remember, just like normal debt, it's going to grow over time. So exploits, which might be 0 days, they make their way into kits, and then they become something that is a script kiddie or a low-hanging fruit attacker can do it. Automated scanners then eventually will be able to detect your weaknesses. And then maintaining legacy appliances get more costly. And then vendors stop patching old appliances. If you look at the Android phones, at least in the US, unless you have a phone from the last year, you're not going to get any patches, even though there are security vulnerabilities in Android. The difference is that, the difference between information security debt and I would say technical debt is that technical debt would be a fixed price mortgage rate. And so it's going to kind of increase steadily over time. Though I would say information security debt is much more like a variable rate mortgage in that you could have a pretty strong security posture. You will have identified some threats, but they don't seem like they're going to be very risky. And then news comes out that there's an exploit, a zero-day exploit that comes out for one of your applications you have running on your DMZ. And then that's all of a sudden your debt and your risk has just jumped up substantially. And so that's kind of something where you're kind of taking on an unknown amount of risk with your technical debt. So that's something also to consider, just like when you're considering getting a fixed rate or a variable rate loan. So we're going to wrap up real quick. I just want to say that a sufficiently determined attacker will be able to find a way into your network. You need to be able to model the risk and the adversary more importantly than the actual tactics and techniques, and then protect accordingly based on who you're trying to prevent yourself against. And then if you're being specifically targeted, you're already failing. You need to prevent the operational security standpoint from getting to the point where an APT threat is looking at you. Security can't wait until the end to be tacked on. If you invest in it very early in product design, so if you put your security folks in bed with your developers, you're going to save costs and improve performance and results. And then also, information security could provide an ROI and bolster your brand. I think there should be some questions and some discussion. So I'll open it to the moderator.
Great presentation, Jacob. Thank you. I love this, the 4 attacks that you mentioned, and the TCB, quite a few interesting stuff that I learned today. So I got a question for you. When we compare between Microsoft or Linux and Apple, how do you rate their security in terms of the operating system security? So you are a researcher, so from your perspective, what do you find are the pros and cons, and whom do you find more secure than the other?
Great question. And so I think that, so we'll just kind of go through one by one. So Windows has made great strides. They got beat up kind of in the early 90s, or mid 90s and the early 2000s, and their security was pretty terrible. And then they implemented kind of the secure software development lifecycle, which really has become kind of a model for the entire industry. And so they've really made great strides. So that blue pill attack, the hypervisor attack, that won't work in Windows 8 because Windows 8 by default will insert just an empty hypervisor in there to prevent another hypervisor from loading, and they will actually prompt the user saying, hey, someone is trying to load themselves into a very privileged spot. Is that something that you're doing? Did you try to run VirtualBox or Zen, or is that something that you weren't expecting? And so that I think is a great step forward. Windows 8 64 also removed a lot of backward support for DOS, which is where a wealth of bugs were. And then also now they've used they moved to EFI, which is a more secure BIOS. And within that, they've actually added some trusted secure boot, and so that allows you to make sure that your Windows operating system hasn't been compromised. So before that, you didn't really realize, if someone had kind of modified a kernel DLL or a kernel file, you weren't really sure who you were trusting anymore. And now, the Windows 8 with this trusted boot will actually have, signed updates that, you can verify have come from Microsoft. So you're kind of minimizing your TCB right there. And so that's really great improvements from Windows. And I think that, if you look at the Pwn to Own, which is a hacking contest held every year where you get, you can go to one link on one computer for OS X, Linux, and Windows. And if you can hack that computer, you get to, the very expensive computer that was running as a kind of a gift and $10,000. And so it seems like lately Windows has been the hardest to compromise. And they've been doing a very good job of being very proactive in preventing zero-day attacks, as well as kind of verifying that what they do have in the kernel hasn't been modified. So Windows, I think, is doing very, very well, and I think for the most part is really up there. The issue with Windows is there's a lot of legacy applications which you might need to turn some of those features off for, and that's really your risk with Windows. Linux, I would say, supports all these features as well, but it requires a huge amount of manual configuration. So Linux can prevent some of these hardware attacks, but you need to put in special code into your kernel boot options, which don't come by default. And so there's a lot of things that you kind of need to, just like in Linux, typically you kind of you have a toolkit and you have a lot of different options, and you really need to configure that system specifically. And so I would say out of the box, Linux is much more difficult to get kind of from turnkey solutions, more secure. OS X, I think, is also trailing a little bit more, and I would say that it's trailing more so than Linux because sometimes a lot of those options just aren't exposed to the user. They're doing a really good job in their iOS security, and I see a convergence between iOS and OS X, but currently I would say that just very recently they moved to a 64-bit kernel which had strong anti-return-oriented programming attack defenses. So I would say that they're behind the curve, and generally they're compromised faster than the Windows counterpart.
So that's very interesting, Jacob, because if you just look at the common man's perception, they somehow feel that Windows is a lot less secure. But I mean, we in the field of security, we know that Microsoft really made some great contribution in the field of security, and they were at one point of time very, very insecure, and there are probably a lot of these vulnerabilities and attacks on Windows, but the reason why they're attacked is probably because they are more popular and not necessarily because they're more insecure. So it's great to know what you mentioned about the Windows and Linux and OS X. And I got another follow-up question related to this. We also got this mobile the mobile operating system, the desktop or the server operating system, then the virtual operating system. So among these flavors, how do you see the security as? Like, which of these ones are more mature, and what are some of the common pros and cons?
Sure. So I would say that, in the mobile space, iOS is a clear front runner. It's very, very difficult to jailbreak your iPhone lately. I mean, for the developers creating the jailbreaks, and the isolation between different applications is very strong. They also have now a lot of trust and measurement built into their capabilities. You can actually find Apple's security designs for iOS. It was an excellent read. And so they're really doing, I think they're the head. What you sacrifice is the ability to say, I would say, own your device. And so we're kind of on the PC side and even the desktop and Mac laptop side, we're used to being able to kind of go under the hood and change certain features and being able to do what we want, write untrusted code and have full access and have administrator access. iOS is really trying to kind of gain people's tolerance for not having administrator access on a device that they own, which is from a business perspective is excellent. They can create a walled garden. They can really tie you in there. From a security perspective, it's also really good because I would trust an Apple security engineer more than I would trust the average user of a mobile device. And so by kind of removing those abilities to kind of shoot yourself in the foot, Apple's doing a really great job. Android is more from the Linux perspective, and so they're a little bit more, a lot of times it's very easy to root your device, or it's something that you can kind of just configure, and it's, you can unlock your bootloader very easily to give you that full Linux environment and to be able to really own your device. But at the same time, it's also been very easy for an attacker to do that and be able to kind of escalate out. And so you'll see a lot of Trojan applications and privilege escalation attacks against Android, where you'll see much, much fewer for iOS. And I think that, as that iOS model becomes more and more accepted and mainstream, I've also seen OS X become more and more constrained as well. So now, if by default you open an application that's not signed by Apple on your OS X system, it won't let you run that application. You have to go and specifically allow that application. So that's something that, you're kind of seeing is it's kind of preventing this, it's kind of pushing this App Store and walled garden and everything is safe in here model down to the desktop. And so I see that kind of as that, the average user sees that as becoming more and more acceptable. I think that the operating systems running on your desktop and your servers will begin to improve as well in that same, as long as you're willing to make that trade-off. Server systems, those are ones where you need root access. You need to be install custom software and be able to, tune the kernel and the performance. And so those are going to be, typically, Linux or Windows, but those ones are typically run by a much more, experienced system administrator. And so I see that, turnkey Linux and Windows solutions now are running under hypervisors, providing more isolation and more of a VPS environment where even if there was a compromise, it's only maybe one application and it can't break out of the hypervisor. So that's kind of across the board. So I think that iOS is in the lead, and I think iOS will start to change how users view device ownership, and that will slowly kind of bleed through into laptop and desktops, and then security will follow from that.
That's a great point. Sometimes having less control is good. Less choices and less control could be good for us, though we tend to go and choose for, more choices, but sometimes it's bad for us. I got another question. I remember in our team, there's quite some time back, we discovered a way to break the encryption of Microsoft BitLocker. So some of the guys at IVIS, Jonathan Brossard, he did this research. We later on presented at DEF CON. And I remember in that attack, we actually did not break the encryption. What we did was we figured out a way to go and steal the password, which was being stored in plain text in the BIOS, and the reason why they did it in that manner was from the user land the BIOS was not accessible. So the researchers figured out a way to kind of exploit that trust. And I remember you spoke about trusted computing base, and the question is, how do you, as a practitioner, what are the real practical ways to kind of deal with the trusted computing base related security risks?
Sure. So I think trusted computing and probably stemming from that attack is becoming a much more practical solution now. So Intel is rolling out what's called SGX, Software Guard Extensions, which allows you to run almost every application in a completely isolated and protected memory space. And so that would allow kind of BitLocker to run in a protected environment that's measured and kind of tied back to a TPM, which has also become deployed across most computers, a trusted platform monitor. And so I think that what we're seeing is we're seeing roots of trust rather than being into the BIOS, which used to be kind of considered untouchable and prevented, just like when when the BitLocker was developed, and then moving that into something like a TPM, which is a hardened chip on your motherboard that has a separate interface and then also has special crypto controls. And so I think BitLocker now, I believe, it allows you to tie it to a TPM, so the password's actually not in memory. And so I see that between that and then SGX, which is a very dynamic way where your trusted code base can become almost nothing, where you can load an application and then just that application's code is running almost as if it's completely isolated, and no other applications can read into that application's memory or snoop on the bus, and it prevents against a whole class of attacks. So this has just come out very recently, and I think it's going to take a little while for it to kind of filter down into what you'd see on your mainstream vPro business class systems. But it's very exciting to be able to basically do a live launch and a live trust measurement on demand for an application. So I think that's really what's going to be kind of the future and where the current state of the art is in that regard.
Wonderful. So thanks a lot, Jacob. This had been a really wonderful session, and we're just doing this webinar just prior to the holidays and stuff like that. So we actually got some of our members reaching out to us and asking if we will be providing the recorded webinar or not. So clearly there's a lot of excitement towards this topic. So what we'll do next is we'll have this recorded webinar broken into some small pieces, and we'll upload it so that those who could not join us today because of the holidays could view it later, as well as the rest of the members at CISO platform. So thank you, Jacob, and thanks everybody who joined despite this being the second half of December. And we will be having more such great webinars soon. In January middle, we'll have another webinar which will be part of the Best of the World series. And apart from even Best of the World series, we will also have other webinars and webcasts coming up soon. So thank